next topic that we are going to discuss is finding the value of function, right? Finding the value of function. Okay, so this would be a very typical type of example. Say, finding value of function. Right, before we get into an example, let's talk about function in general, right? Function in general. We can think of function as a box that has a name. So this is function. I think of function as box that has something goes in and something comes out. The box that something goes in and something comes out. So whatever the value that goes in is called input value. And whatever the value comes out from this box, when this input value comes in, that's output value, right? Output value. I mean, we've seen a lot of this fx equals something something. For example, let's say 2x plus 5. Now, what does that really means? See this f, this f is function name. Function name. So, you know, sometimes you have this f of x, sometimes you see g of x, sometimes you see h of x. You know, you can have w of x. You can call it whatever that you want, right? They usually use f for function, but you know, there's no particular reason that we use this f. You know, if it's about height, they usually use h. If it's about weight, they use w. If it's about time, sometimes they use t, right? So, you know, all this f means just the name of the function. Now, what about this x? What is this x? This is input value. Input value. So what does this mean? This is the name of function. This is just saying that this value is going to be the input value. What about this right hand side? This is going to be output. Oops. Output value. You know, in the beginning, I was kind of confused because, I mean, I can understand this is a name and this is an input value. I mean, wasn't that clear? Whatever that's supposed to mean, I guess that's what it means. But why this is output? Why do we call this is output? Well, think about this. If x goes in, what's it saying here? What does it saying? That x is going to be multiplied by 2, and then to that result, we're going to add 5. That's what it means, right? 2x plus 5 means whatever the x, we're going to multiply by 2 and added 5. So what's happening inside this box? Well, what's happening inside this box for this function is that whatever that goes in is going to be multiplied by 2, and we are also going to add 5 to that result. And that result is going to be put out as output value. That's why we call this side is output. So let's say, example, let f of x, the function that we are dealing with, is 2x squared minus 3x. Evaluate let's say first one is f of 1, for example. Evaluate this. Well, what's that supposed to mean? Well, check out the input value. What's the input value? This is input value, right? Input value is 1. So, input value used to be x. If it's x, then that x is going to be squared and multiplied by 2. And to that value, we're going to subtract 3 times of whatever the input value. Now, input value is not x, it's 1. So all we really need to do to figure it out is just change x to 1, as it says here. So it'll be 2 times 1 to the square minus 3 times 1. What I did is just replace this x by 1. So what's that going to be? F of 1 is 2 times 1 square is just 1, so it'll be 2 minus 3, which is minus 1. That's our answer, right? Not too bad, right? Okay. Now, what about f of, say, a? Now, take your time and think about this. What's f of a is going to be? Well, now what's our input value? It used to be x. Now, our input value is going to be not x, but a. So this is easy too. I mean, all we need to do now is just replace x by a. So it'll be 2a squared minus 3a. That's it, right? That's it. Okay. What about this? Let's say f of x plus h. What's that supposed to mean? What's our input value? Well, don't get confused. See this inside, this is input value, right? So all we need to do now, replace that original x, the input value, by our new input value, x plus h. So f of x plus h means 2 times what used to be x squared now become x plus h squared minus 3 times what used to be x now become x plus h. Right? Think about it. What was our original x? F of x? Original f of x, this. Right? Now we replacing that x by x plus h. That's all we are doing. Right? That's all we are doing. Well, are we done? Well, not quite yet, because we need to simplify this. Now, if you know how to expand this, if you remember that formula and all that, this part will be expanded as x squared plus 2x hx, xx, same thing, but let's say 2hx plus h squared minus 3x plus h. So this x plus h, I'm not going to touch it. Okay, now what's that going to be? Well, if we multiply it here, and here, it's going to be 2x squared plus 4hx plus h squared minus 3x. I'm multiplying this minus 3 in here. And be careful because we are multiplying minus 3 to h, so it's going to be minus 3h. Right? Minus 3h. All right. So, I mean, technically we can simplify, but, we can factor it and simplify, but I don't think we need to. So we can just leave it like that, and that will be more than 5. That would be more than 5. Now, the ultimate question for this example, part D, is to figure out f of x plus h minus f of x over h. I mean, this may seem very strange. What is this? I mean, why do we need to find this rather not attractive, complicated looking math equation? Well, you know, when you actually take a couple of other math course when you're studying calculus, they're gonna do differentiation, whatever that is, and this would be the basic, one of the basic idea of differentiation, how to differentiate function. But we don't need to know that now. We're just going to try to figure out this. Well, the good news is we already know what this is. Well, it's right here, right? We know what f of x is because what was f of x? F of x was 2x squared minus 3x, right? That was f of x. So we can just put this in here over h. So it's practically all given. So let's see. So this, I'm going to write this. 2x squared plus 4hx plus h squared minus 3x minus 3h. That's this part. Minus. So all that is f of x plus h. Minus. What's f of x? Is this. So it'll be 2x minus 3x. So that's f of x part over h. All right. Now let's see what cancels out. See this 2x squared minus, when we apply this minus, we have this minus 2x squared, so this will cancel out. What else? We have this minus 3x. When I apply this minus inside, this would be plus 3x. So that will cancel out with this. So what's left behind? Well, we have 4hx plus h squared minus 3h. This, and this over h. Well, notice that we have h here, here, here. So why don't we factor out the h? Then this would be 4x plus this would be h minus 3 over h, right? Remember, we factor out the h, we have h squared, so we have two of them, so we factor out one of the h, then we have h minus 3h. So we factor out the h, then we have this. Now, if you are not sure what's happening in here, you should go back to the factoring chapter, then make sure that you know that skill. I mean, you know, math is very sequential subject. So since we already passed that part, the factoring part, now this course and also me will assume that you know this technique. So I'm gonna do all this, you know, expansion and factoring, assuming that you know. You know, that might not be the case for some of us. If that's the case, then you should definitely go back to that chapter and restudy that. Otherwise, it'll be very difficult for you to catch up, and you will end up not liking this beautiful subject, math, and you will not like this course. You will not like me. You know, who would want that? Right? I don't want that. So I want you to go back to that chapter, the factoring, study that chapter, make sure that you understand, right? Then this will all make sense. Now we have h on the top, h on the bottom. So what do? We cancel it out. So what's our final answer? Final answer would be 4x plus h minus 3. Right? So that horrible looking long equation now become this nice simple thing, right? Which is nice. Okay.